Very good morning, one and all. Today, I hope the test we carried out yesterday was hopefully all of you have done well. But while answering the test to while answering this online test, please ensure that your wholehearted cooperation, I would say the sincere cooperation from your side, need to be there because all these tests are carrying out for your benefit. And so, put your effort sincerely, try to answer the question. So, this is a self evaluation. Also, you are doing it by yourself. See, as I told you before, so you have to be more engaged in such activities. Otherwise, you cannot complain about the time. Okay, I'm not going to discuss much about it. I hope all of you are safe and be at home. We are moving on to the last module of. We have few topics in the last module like the power transmission elements, which will be covered in upcoming two lectures. And today I'm going to cover the last module of the syllabus, which is mainly comprises of the manufacturing processes. And in this lecture, we are going to discuss about. I'm going to give a basic introduction and a basic description of the manufacturing processes. Now, before going to start this manufacturing, I would like to say you take a few moments and inspect various objects around you. Your pen, your shirt, your clothes, your watch, your table, your chair, the mobile phone, the laptop, telephone, yeah, of course, calculator, watch, many things you can find around you, isn't it? If you are sitting in a room. And you may realize that these objects had a different shapes, isn't it? And also, very interestingly, I can say that you cannot find them the you cannot find them in nature as they appear in your room. Am I right? You cannot find them in nature as they appear in your room, which means they have been transformed from various raw materials and assembled into the shapes that you now see, which means some transformation takes place in between. Am I right? All these objects which I have mentioned just before as examples, transformed from various raw materials. Sometimes some individual components are assembled into, and you get the shape that you now see. Okay, so uh, here lies the importance of manufacturing process. So I told you some transformation takes place. So this transformation is facilitated by the branch called manufacturing. Now let's jump into the lecture directly. So the word manufacture, which is derived from a Latin manufactus, which means made by hand, and the word manufacturing and the word production. Sometimes these two words used interchangeably, the production and manufacturing, and it appeared sometimes during 15th century. Now, as per the initial discussions, I can tell you what do you mean by a manufacturing or what do you mean by a production. The production of a component involves transformation of a raw material or transforming a raw material from its original state to finished state by changing its size, shape, and properties in a series of steps. Isn't it? You have a raw material with you, you are transforming this raw material to the component you want, or transforming from the raw material to the original, I mean the from its original state to the finished state by changing size, shape, and properties in a series of steps. And each step is called a manufacturing or production process. So when, for example, when no further changes are required, the component, the component which we obtained is called a finished component or a finished part. Okay, so actually the subject manufacturing processes which we are going to explore in this module, which actually deals with the various aspects of production of a component or the production of a finished part and the selection of a, so which process we will select to produce the best, produce this part. There is a selection of a best process for a given part. In order to select the best process, for example, if you want to make a chair or a table or whatever it may be, so which manufacturing process is best suited for that? How you will come to conclude? You know, you have to know about all the manufacturing processes, almost all, which is relevant to that part, isn't it? So hence, we are going to deal with all the basic manufacturing process in this subject. Um, yeah, so the subject manufacturing process deals with the various aspects of production of a finished part. Now let's see, this manufacturing process can be broadly classified into 5. So this is a broad classification. I can classify it into a shaping process, machining process, joining process, finishing process, property changing process. What do you mean by a shaping process? So these are the process in which the shape and size of the material is changed without removal of the material. Please underline that sentence. Without removal of the material. You are going to change the shape and size of the metal without removal of the material. So these are some of the common processes which falls under this category: casting, forging, rolling, extrusion, drawing, etc. Now the second one would be the machining process. See, sometimes the shaping process will give you a part which is not um, suitably finished for commercial use. Yeah, when you make a component, it should be capable of serving the purpose of the application, isn't it? Sometimes if a component you have obtained using the shaping process, for example, you cannot use a component which you have obtained directly from the casting sometimes, because maybe the surface which have a lot of bundulations and you need to machine it, the surface. That is a second classification, machining. So these are the process in which the shape and size of the material or metal is changed by removing the material from the unwanted portions of the workpiece. Earlier shaping process, you are not removing the material, but you are changing the shape and size. And in machining process, you are changing the size and shape by removing the metal from the unwanted portion of the workpiece. Usually, as very clear, these are carried out after the shaping process. Okay, the common process which falls under this category are: one is surfacing, turning, drilling, grinding, milling. maybe during your basic mechanical engineering workshop, you may have gone through see this kind of instruments in our manufacturing technology lab. Okay, and the third classification is the joining process. So joining process are those processes in which two or more parts are joined together. Okay, like what are the different joining processes? As the word implies, welding, bracing, soldering, bolting, riveting. So you are joining two or more parts, or the two or more parts are joined together by these techniques. Next one would be the finishing process. So these are the process by which the required surface finish is provided to the part. Yes, when you are going to use the part for the final application or end use, yeah, the component should serve the good surface finish. It should not have some sharp edges or corners. Example, some maybe a lot of requirements will be for the part you are going to use or the component you are going to use. So the finishing process are those processes by which the required surface finish, maybe sometimes a protective coating will be provided to the part. Okay, it's not a treated as a metal removing process, but even though some small amount of metal removal or addition takes place. Okay, the common process falls under this category are honing, lapping, electroplating, galvanizing are the examples. And the last one would be the property changing process. Are those processes in which the certain properties of a part is changed so as to make it suitable for particular application. For example, you know about different heat treatment techniques like annealing, normalizing, hardening, tempering, isn't it? These processes will change the properties of the material, sometimes mechanical properties, heat resistance properties, thermal properties. So these are the 5 different common classifications of manufacturing process: shaping, machining, joining, finishing, and property changing process. Now let's directly jump into one of the very important process called casting. So this is one of the basic manufacturing process. Yeah, in order to easily explain the casting, maybe some of you already hear about this term casting, isn't it? Maybe you may have done some projects, maybe during your schooling or sometimes. Or those who are not familiar with this, I will say this casting is similar to a process of ice making. Maybe either all of you have seen how an ice is made, right? Because the casting is similar to the process of ice making, which means if we keep some water in a bowl and allow it to frozen, we will get a piece of ice as per the shape and size of the bowl, right? And the piece of ice can be called as casting, and the bowl can be called as mold. Okay, so this is a very easy example to a casting. The same way we are going to do the casting. You are going to pour, instead of pouring water to the mold, sorry, the bowl, you are going to melt the metal and pour this molten metal into the mold and allow it to solidify or frost. So if you can imagine the ice making process, that is similar to a casting. Okay, so how can we define casting? The casting is the process of producing metallic parts of desired shape and size by pouring the molten metal into a mold having a cavity of the part to be cast and allowing the molten metal to solidify. അപ്പോൾ നമുക്ക് ഏതെങ്കിലും ഒരു കമ്പോണന്റ് ഉണ്ടാക്കണമെങ്കിൽ കാസ്റ്റിംഗ് എങ്ങനെയാണ് ചെയ്യുന്നതെന്ന് വെച്ച് കഴിഞ്ഞാൽ നമുക്ക് ആ ഡിസൈഡ് ഷേപ്പിലുള്ള ഒരു ക്യാവിറ്റി ഉണ്ടാക്കണം ആദ്യം. Yeah, now I know you are familiar with the molding process അല്ലേ? നിങ്ങളുടെ ബേസിക് മെക്കാനിക്കൽ എഞ്ചിനീയറിംഗ് വർക്ക്ഷോപ്പിൽ you made the sand mold. You know how the pattern can be made and how the mold can be made, and maybe you may not have done the pouring of the molten metal. And once the shape is made, you pour the molten metal and you will get the desired shape. Okay. Now, so that is what we are coming to discuss. The most popular way of metal casting is by using sand as the mold material. So that is called the sand molding process, and the casting is called the sand casting technique. Okay, sand casting technique. So the metal casting process is also known as foundry. Foundry, and again, this industry, the metal casting industry, is also having the name foundry. Now, yeah, you know what is mean by a molding process. എങ്ങനെയാ molding ചെയ്യുന്നതെന്നൊക്കെ നിങ്ങൾക്കറിയാം. You know how to make the molding. എന്താണ് molding? For example, what is sand molding? You have done it, isn't it? The process of making mold using sand. The process of making mold using sand is called the sand molding. Now let's see what are the different steps in a sand casting process. ഏതൊക്കെയായിരുന്നു? Pattern making. എങ്ങനെയാ pattern making? Core making, molding, melting and pouring, solidification, shakeout and cleaning. ഇതൊക്കെയായിരുന്നു ഇതിലെ important steps. And then what is how the pattern is made? What is pattern? The pattern is the replica or model of the shape of the product to be made by the casting process. Using this pattern, what you can do? A mold cavity is made to which a molten metal is filled later. Okay, using this pattern, you can make the mold cavity. So the first step in this process is the pattern making. Usually, wood, maybe in your basic mechanical engineering workshop, you have used a wood pattern. Again, you can use a metal pattern, wax pattern you can use. A plastic can be used as a pattern. Then core making. And then core. See, if you want to make a hollow casting, how you will do? Just imagine you made a cavity and you are going to pour the molten metal. You are going to make pour the molten metal. Usually you will get a solid casting, isn't it? How you will get a the hollow casting? Hollow casting കിട്ടണമെങ്കിൽ, so when you pour the molten metal, ആ molten metal hollow ആയിരിക്കുന്ന പാർട്ടിൽ fill ചെയ്യാൻ പാടില്ല, അല്ലേ? If you imagine, you can that is the easiest way to think. So if the casting is if you want the casting is hollow, we use additional patterns called cores. Okay, and the core which acts as an obstruction to the molten metal flow. അതായത് wherever you put the core, the molten metal will not come and fill that region. As a result, you will get a hollow casting. And another one is the molding. Yeah, you know, it's a process of creating a cavity. If it is a sand casting technique, you are going to create a void or cavity in a compacted sand mass with the help of a pattern. So the process of creating a void or a cavity in a compacted sand mass with the help of pattern. And you know that you may familiar with, along with the molding, you will do some passages made for the entry of liquid metal into the mold. Maybe you have heard about the gating system and the provision to supply of additional metal to compensate the shrinkage. You will given risering, gating system, risering. All these names you are familiar with, I hope. And then the next important step is the melting and pouring. Once the mold is ready, metal is melted in the furnace and then it is poured into the mold cavity through the gating system. And the next step would be the solidification. So along with the pouring, cooling of the liquid metal starts and the metal solidifies. So during the cooling and solidification, what will happen? The metal shrink its size and acquires the solid structure. And next, shakeout and cleaning. So when the solidification is completed, the mold has cooled down to the ambient temperature or the room temperature, the casting is removed from the mold, and this process is called the shakeout. You are shaking out the component from the sand mold. So these are the important steps: pattern making, core making, molding, melting and pouring, solidification, checkout and cleaning. These are the important steps in a sand casting process. Now, another important terms you must know about is this. If it is a sand casting process, we are going to discuss first about the sand casting process. So that's why I discussed all the terms in connection with the sand molding. So when you are going to use the sand as a molding material, so the should possess certain properties. Let's see what are it. One is the porosity and the permeability, cohesiveness or strength, adhesiveness, plasticity, refractoriness, flowability, chemical stability. Let us discuss one by one. The first one would be the porosity. What would be the porosity? Or I will say permeability. See, when you make എങ്ങനെ ഈ molten metal ഉണ്ടാവുന്നത്, you are going to melt the metal. If it is a copper, tin, aluminum, ഏതാണെങ്കിലും you are going to melt it. എങ്ങനെയാ മെൽറ്റ് ചെയ്യുക? ഓരോ മെറ്റലിനും ഒരു മെൽറ്റിംഗ് ടെമ്പറേച്ചർ ഉണ്ടാവും. അതിന് മുകളിൽ ഇതിനെ ഹീറ്റ് ചെയ്യണം. മെൽറ്റിംഗ് പോയിന്റ് ഉണ്ടാവും. Okay. So once the molten metal is ready, so you please note that the molten metal always contains some amount of dissolved gases. So which comes out when the metal solidifies. So as the hot metal comes into contact with the mold, what will happen? The moisture content gets converted into water vapor or steam. See, the mold sand should allow these gases and the steam to escape through the mold walls. When you pour the molten metal into the mold cavity, ഏതായിരുന്നു mold cavity? Which is made up of sand mold. അതിനകത്തുള്ള ഈ ഗ്യാസസ് ഒന്നും ഇതിനകത്ത് എൻട്രാപ്പ് ചെയ്ത് കിടക്കാൻ പാടില്ല. അത് പ്രോപ്പർലി പുറത്തേക്ക് പോകണം. അതുകൊണ്ട് permeability, it should permeate through the walls of the sand mold. It should not be entrapped in the mold cavity. If it is entrapped, it will finally result in the defects. So this property of sand is called the permeability or porosity. So if the sand is not having sufficient permeability, then the gas will be entrapped in the liquid metal and may form some kind of defects. So how you can improve the permeability? Do a soft ramming. You might have done ramming to make the mold. Do a soft ramming, and if you can add some clay content, it can improve the permeability. So that is a porosity or permeability. The sand should be permeable. The second property would be the cohesiveness or strength. So it is a property due to which the sand particles stick together. So sand particles നന്നായിട്ട് stick together ആവണം. എങ്കിൽ മാത്രമേ ഈ നമ്മുടെ മോൾഡിന് സാൻഡ് മോൾഡിന് നല്ല സ്ട്രെങ്ത് ഉണ്ടാവുള്ളൂ. So okay, the molding sand should have sufficient strength so that it should not collapse or it gets damaged during the preparation or use. So that is called the cohesiveness, property due to which the sand particles stick together. Next is adhesiveness. എന്തായിരിക്കാം? It's a property of the molding sand due to which it adheres to the surface of the other materials. For example, നമ്മുടെ ഈ sand, when you are going to make the sand mold, what you will do? First you will put the sand in the molding box and then ram. അപ്പം due to this property, that is due to the adhesiveness, the sand adheres to the walls of the molding box. നല്ല adhesion വേണം molding boxന്റെ walls-ഉമായിട്ട്. So that property is called adhesiveness. Next one is called the plasticity. What would be the plasticity? Can you say what do you mean by the plasticity? Actually, this is same as the flowability. നമ്മുടെ താഴെ എഴുതിയിട്ടുണ്ട് flowability. Okay, both are almost same, the plasticity or flowability, because it is a property of the sand due to which the sand can be compacted to uniform density. So this property helps the sand to flow and pack around the pattern, filling all the parts of the molding box. So actually this plasticity or the flowability, which depends upon the clay and water contact. So it is a property of the sand due to which the sand can be compacted to uniform density.
and it helps the sand to flow and pack around the pattern, filling all the parts of molding box. Then another property would be refractoriness. എന്തായിരിക്കാം refractoriness? So what we are doing, how you are making the casting, you are melting the metal, molten metal is made, you are pouring the molten metal into the cavity, and when you pour this molten metal, you please note that this molten metal, okay, ഭയങ്കര high temperature ആയിരിക്കും. So if it is the melting point of the metal is very high, the molten metal which you prepared will be also having high temperature. So നമ്മൾ ആ molten metal ഒഴിക്കുമ്പോഴേക്കും ആ മോൾഡ് ഹൈ ടെമ്പറേച്ചർ ആയിട്ടുള്ള molten metal നെ withstand ചെയ്യാനുള്ള capability ഉണ്ടായിരിക്കണം. So it is a property of the molding sand by which it can withstand a high temperature of liquid metal or the molten metal without any physical change. So that property is called the refractoriness. നല്ല refractory material ആയിരിക്കണം യൂസ് ചെയ്യേണ്ടത്. Usually some kind of ceramic coating is given to sometimes to the molds to withstand the high temperature molten metal. Next one would be the chemical stability. What would be the chemical? It should be chemically stable. It should not react with the, when you pour the molten metal into the sand, it should not be chemically react with the sand you made. So that's all about this lecture. So we will come out with another episode soon.